And again, because the symmetry restrictions didn't hold, I did the elasticities. In my answer key, I did the elasticities both ways for each factor pairing, and there was not much conflict in most cases. Let's look at, we looked at it across the different ways. So capital fuel pair, there was a t-statistic, although the t-statistics were different in sign, 0.24 versus minus 0.8. Basically, either way you computed that elasticity, you would say that it's 0. For capital labor, again, there are two ways to do it. This time, definitely the elasticity is positive, because in one way you do it, you get 4.1, the other way you get 2.8. Looking at capital and materials, now this was one of the problematic ones. Capital is a problem because we have stocks instead of flows. How you measure materials, that's always a little troublesome. In this case, one result says that the elasticity is not different from 0, and the other one says these guys are definitely complements. If you look at electricity and labor, definitely the elasticity is positive. If you look at energy and materials, there's a little contradiction. That deserves further thought. And if we were writing a research paper, we would say we've got a problem in this pairing. Labor and materials, again, the elasticities look like they're 0. The own and cross price elasticities, the same kind of algebra that was involved in deriving the Allen elasticities, or you could just look them up in green and give the citation. I found the answer in green and write it down. Calculating the elasticities at 1971, again, for each pair, now there are 4 ways to do it. Because of the fact that the symmetry restriction didn't hold, I didn't ask for everybody to do all 4 ways. If you just showed me that you knew how to do it for one way, that was fine. Again, I wasn't trying to hammer people down. So it looks like a bunch of the key statistics for capital and fuel are essentially 0. And so if you raise the price of fuel, the quantity demanded of capital nothing happens to it.
So that means they're complements, right?
No, it means they're not related. They're independent of one another. Capital and labor.
Negatively.
Right. So again, for all the pairs, you got 4 different ways to do it. And in your answers, you would have some discussion about the conflict between the answers and whether or not they're complements or substitutes, and so on and so forth. Okay. On these Allen elasticities, this is the cross elasticity for the Allen, but many of you also reported the own Allen elasticity. What's that one all about? The Allen elasticity of substitution, and you're only looking at, you're computing a sigma II. How could that be? I didn't get an email from anybody asking what's the meaning of sigma II.
It's a second derivative.
But what were the first couple of questions about on the assignment? Homogeneity and scale.
So it's constant.
Right. So the Allen IIs tell you something about scale. The cross elasticities tell you something about the substitutability between the inputs. Incidentally, is becoming familiar with this technology of any value to somebody in financial engineering? Sure. Don't you have risk-return frontiers?
Yeah.
Aren't risk and return a trade-off? Or when you construct a portfolio, don't you have a trade-off between stocks that you can put into the portfolio?
Sure.
Some are substitutes, some are complements. So with some thought, you could think about portfolio construction and use this approach to quantify the elasticity of substitution between a mid-cap and a large-cap stock in your portfolio, or the elasticity of substitution between stocks drawn from Asia and stocks drawn from the U.S., or the extent to which they're complementary. So, if you stop and think about things for a while, in a semester-long course, you're in a big rush to get everything done, and so you don't always have time to stop and think about them. But sometimes if you have some time to think, you reflect on things that you had to do in different classes, you'll see that you can connect a lot of different technologies together that you're learning about. Okay, so let's go on here. So the own price elasticity. These will tell you whether or not the demand curve is downward sloping. Whoa, doesn't look well. Capital seems to be flat. Labor looks like it's downward. The demand for labor is downward sloping. Demand for energy is, let's hope that it's not upward sloping anyway. And the demand for materials is at some wide, given we only have 25 observations, if we had a very high level of significance, like 10%, we might be able to squeak it in there as the demand for materials being downward sloping.
One is regression, like the history. When we run regression on the estimate
I just commented on that. You get the p statistics from gamma ij. But this is why I had this here. Knowing that gamma ij is different from 0 is not the same as knowing it's different from SISJ. This was the comparison. Not in that question. If that was the comparison that you argued, that was wrong. There is a way to approach it that way, and this is the way to do it. Okay. So again, just be careful and think about it.
It always tells you the gamma ij, the difference 0.
The p statistics that you get from the computer printout compare the estimated coefficient to 0. Sometimes you don't want to make that comparison. You want to make it different. Yes.
We found alpha 1, alpha 2 before.
Excuse me?
When you found alpha 1, alpha 2, alpha 3, alpha 4 in the regression, did you test some single one?
Maybe, was it supposed to be 0?
I think it's supposed to be 1, some of the alphas. I wasn't sure if you did that, or if you figured it.
Yeah, I subtracted off 1.
But if there's different regressions, how could you find,
Thank you for bringing that up. So we have all of these equality and symmetry restrictions that we believe are supposed to be present. So we should have estimated the 4 Scher equations simultaneously with the imposition of those 5 plus 6, there's 11 constraints. So if you read carefully the section in green where he used this data set, he did talk about how to do that. But I didn't ask you to do that. The way we would do, if we were to do this homework again in the spring semester, we would use Zellner's seemingly unrelated regression with constraints. And then we could impose the symmetry and equality restrictions at the time of estimation and guarantee that they held. And then we could go on and ask another set of questions. And we could construct an F-test on the 11 restrictions. Estimate them once by seemingly unrelated with the restrictions and once without, and construct an F-test. But I didn't want to, and constructing these seemingly unrelated regressions now is just a problem of clicking buttons in your software. But the homework was hard enough without having to do that also. I tried to keep it as simple as I could. Laura doesn't believe me. She thinks my goal in life is to make everybody's life difficult. You second it, huh? Anybody else? Yes. What's seemingly unrelated regression? Well, Jeremy just pointed out we have 4 factor Scher equations. The 4 factor Scher equations are estimated from U.S. manufacturing. So in 1959, we observed the data necessary for these 4 factor Scher equations. So whatever was bothering one of the factor Scher equations in 1959 was probably also bothering the others. So there should have been some correlation between the equation error terms. And so Zellner's seemingly unrelated regression is a way to exploit the fact that the error covariance matrix across the 4 equations is more complicated than just being scalar diagonal. As long as you ask for a little clarification, let's construct do something on the board here.
Doing this, you just estimate them simultaneously, right?
Excuse me?
The nuts and bolts of doing it is you just estimate them simultaneously.
Yeah, I'm going to put it on the board straight out here. Hang on.
Status is a crock model.
I don't know the SAS commands to do it. That's not stuff that I commit to memory. When I need to do it, I get out the manual or I get to know it quickly.